Today we're going to start into Unit 5, which is the graphical application of derivatives. And today we're going to start with Section 5.1, higher order derivatives. In this chapter we'll see how derivatives will help us in drawing the graph of a function. A couple of parameters to start with. If f of x, our function, is a differentiable function, and differentiable means that it's a smooth curve with no jagged corners or breaks, then f prime is known as its first derivative. If f prime is differentiable, then its second derivative is known as f double prime. And all f double prime is, it's the derivative of the first derivative. So this is one form of writing the first derivative, f prime or dy dx, or f double prime, d squared y over dx squared. That means second derivative. So just some different notations to represent first and second derivative. Let's take a look at our first example. They want us to find the first two derivatives of the following. So the first thing we're going to do is find the first derivative. So using our sum and difference rule and power rule from chapter 4, the derivative of x to the 6th would be 6x to the 5th, plus the derivative of 5x to the 4th is 20x cubed. The derivative of 3x cubed would be 9x squared, and the derivative of x is 1. So there's our first derivative. Now the second derivative, which we'll notate as f double prime, is going to be the derivative of the first derivative. So now we do the exact same thing. So the derivative of 6x to the 5th is 30x to the 4th, plus the derivative of the next term would be 60x squared minus 18x, and that's all you have to do with this one. So a very straightforward first example. In example number 2, they're asking us to find the second derivative. So the first thing I have to do is find the first derivative, and for this one I have to use the quotient rule. So to find the first derivative, which is dy dx, it's going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So now I'm going to simplify the numerator by distributing the 2 here. So I'm going to get 2x minus 2, and when I distribute the negative sign in the second part, I'm going to end up getting negative 2x minus 1, and this is all over x minus 1 all squared. Collecting like terms, I end up getting negative 3 all over x minus 1 squared, and that is my first derivative. Now, to find the second derivative, I have to take the derivative of the first derivative. So let's just recopy the first derivative here so we're not bouncing back and forth between pages. And this was negative 3 over x minus 1 all squared. Now, before we take the second derivative, you should have learned from last chapter that because I do not have a variable in my numerator here, I can just move up the x minus 1 squared and make it to the negative exponent, and that's still the first derivative. And now I can use the chain rule to take the derivative of this expression. So my second derivative now, which would be d squared y over dx squared, the negative 2 comes out front to become positive 6. X minus 1 drops to exponent of negative 3, and then I multiply by the derivative of the inside, which is 1. And if you were to simplify this, you could move the x minus 1 down to the bottom, and that would be our second derivative. So, to recall, again, we did the quotient rule first, got our first derivative, got it in a derivative-friendly form, and took the second derivative. Now our next example is going to get quite confusing, I'll admit right off the start, but a lot of it is just the algebraic simplifying and not so much the calculus. So let's go through one just so that we can review some of our previous derivative skills. So in this next example, the first thing I'm going to have to do is I'm going to have to rewrite my radical as a fractional exponent, and then hopefully you'll realize that this is the product of two functions, so I have to use the product rule. So to take the derivative using the product rule, it is the first function times the derivative of the second function, and I'll have to use the chain rule, so the 1/2 comes out front, x minus 1 drops to the negative 1/2, and the derivative of the inside is 1, so there's no need to write that, plus my second function, which is x minus 1 to the 1/2 times the derivative of the first, and there is my first derivative. Now we're just going to simplify this, so this part here can come down with the 2 and the exponent can become positive, so I'm going to have x squared over 2 x minus 1 to the 1/2 plus 2x times x minus 1 to the 1/2. And the last thing I'm going to do before I take the second derivative is get a common denominator. So I'm going to multiply this by 2 x minus 1 to the 1/2 all over 2 x minus 1 to the 1/2. And if I clean this up, I'm going to have x squared over 2 x minus 1 to the 1/2 plus 2 times 2x will give me a 4x, so I just multiplied those together, and those two things multiplied together are going to leave me with an x minus 1, and this is all over 2x minus 1 to the 1/2. Then I have to distribute here, and if I clean this up, I'm going to have x squared over 2 x minus 1 to the 1/2 plus, if I distribute that, I get 4x squared minus 4x over 2 x minus 1 to the 1/2. And if I collect like terms now and put them all over one denominator, my first derivative is 5x squared minus 4x over 2 x minus 1 to the 1/2. Now we have to take the second derivative, which is going to be the derivative of our first derivative. So let's just copy down our first derivative here first. So it was 5x squared minus 4x over 2x minus 1 to the 1/2. And now I'm going to have to use the quotient rule. So y double prime is going to be the denominator times the derivative of the numerator, which is 10x minus 4, minus the numerator, which is 5x squared minus 4x, times the derivative of the denominator, which I'll have to use the chain rule. So the 1/2 comes out front, that becomes a 1 as the leading coefficient, and x minus 1 drops to the negative 1/2. And this is all over my denominator, which is 2x minus 1 to the 1/2, all squared. So we are really done calculus right there, and the rest of this now is going to be algebraic simplifying. So first things first, I'm going to distribute the 2 into this, so I'm going to get 20x minus 8 times x minus 1 to the 1/2 minus this term, because it's a negative exponent, can become a denominator for 5x squared minus 4x. So it's going to be 5x squared minus 4x over x minus 1 to the 1/2. And this is still all over. If I square my denominator, squaring the 2 is a 4, and squaring the x minus 1 to the 1/2 becomes an x minus 1. Now, we have to go a little bit further to simplify this. Remember that this is really over 1, so I'm going to multiply by the reciprocal of that in the next step. But before I do that, I'm going to get a common denominator up top here. So I'm going to multiply this by x minus 1 to the 1/2 over x minus 1 to the 1/2, and then I can combine my terms up top. So my 20x minus 8 hasn't changed. The x minus 1 to the 1/2 times x minus 1 to the 1/2 is just going to become x minus 1. And again, I should have brackets there because when I subtract, I have to distribute the negative sign to both of those terms. So that's going to become a minus 5x squared plus 4x, and all of those are over the denominator, x minus 1 to the 1/2. And I'm going to multiply this whole ugly mess by the reciprocal of the denominator, which is going to be 1 over 4x minus 1. So now all we have to do is FOIL out my two binomials here, collect like terms, and then multiply those two fractions together, and we're done. So 20x times x is going to give me a 20x squared minus 20x minus 8x plus 8. I still have my minus 5x squared plus 4x, and this is all over x minus 1 to the 1/2 times 1 over 4 times x minus 1. So in the next stage, or next step, I'm going to collect like terms. So 20x squared minus 5x squared is going to give me 15x squared. And negative 20x minus 8 is negative 28, plus 4 is going to give me negative 24x. And I have a plus 8. And this is over my denominator of x minus 1 to the, let me erase that there. That's over x minus 1 to the 1/2 times 1 over 4 times x minus 1. Now when multiplying fractions, we multiply straight across, so my numerator is not going to change. It's going to stay as 15 minus x squared minus 24x plus 8. And multiplying along the bottom, I have a coefficient of 4, and x minus 1 to the 1/2 times x minus 1 to the first. I leave the base and add the exponents to get x minus 1 to the 3/2. So there is your final answer, and you can tell looking at the question there's a lot of algebraic simplifying going on. Rest assured, as we move forward throughout the course, there's not a lot of questions that work in that great of detail, but I just wanted to show you one example so that you can appreciate some of the derivative skills that you need to know. Okay, let's take a look at one last question here, and this one we have to find the derivative implicitly, the second derivative implicitly. So let's do the first derivative first. So it's going to be 2x minus, and if you take the derivative of y squared, remember it's 2y times dy dx, and the derivative of 4 is equal to 0. So now I want to isolate my dy dx to get my first derivative. So I'm going to add the 2y dy dx to the right side. I'm going to divide both sides by 2y, and now my 2's can cancel, so my first derivative is going to be dy dx is equal to x divided by y. So I'm just going to transfer that over to the next page. So dy dx was equal to x over y. So now I want to take the second derivative. So to take the second derivative, well, the derivative of dy dx, using this notation, remember, is d squared y over dx squared. And now I have to use the quotient rule on the right side. So it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom. Well, the derivative of y is 1, and I have to times it by dy dx. And this is all over the bottom squared. Again, we're done calculus there. The rest of this is just algebraic simplifying. Okay, well, to do this, I'm going to replace dy dx. We know dy dx is x over y. So in place of dy dx, I'm going to write it as x over y, and this is over still y squared. So this becomes y minus x times x is going to be x squared over y squared. And now I'm going to get a common denominator in my numerator. So to do that, I'm going to multiply this side by y over y. So this equals y times y is going to be y squared minus x squared over y. So there's my numerator. Still all divided by y squared, which is really over 1. So now I can multiply by the reciprocal of the denominator. So I have y squared minus x squared over y squared, that should have been, no, over y, sorry, times the reciprocal of the denominator, which is 1 over y squared. So now if we go along here, I end up with y squared minus x squared all over y times y is y cubed. And you're almost done. If you look back at the original question, okay, the original question was x squared minus y squared is 4. So if I was to factor a negative 1 out of the numerator, it would change the order to that. And now this is equal to 4 in the original question, so my final answer would be negative 4 over y cubed. Quite often when we do the second derivative using implicit differentiation, we end up with a version of the original question somewhere in my final answer. Not always, but quite often. Okay, that concludes our lesson on second derivatives. And again, there's quite a few questions there, so if you find that you understand this material quite easily, you can just do a few of them. You don't have to do them all, but there are some there for you to practice. And again, the answers are posted on the webpage. Take care.